Let's go over to our solutions to functions part 1 exercises. So for the following functions, f of x equals 2x squared minus 5x plus 4 and g of x equals 5 minus 3x, let's evaluate the following. So we're doing function evaluation, so f at 3. So this f means I'm using the f function, and this 3 means I'm inputting for this x and all x's a 3. So into my f function, each of these x's will be replaced with 3, and then I'll just follow my order of operations to solve. 3 squared is 9. 2 times 9 is 18, minus 5 times 3 is 15, plus 4. And 18 minus 15 is 3, plus 4 gives me 7. So the function f evaluated at 3 is 7. G evaluated at 3, this g means I'm going to use the g function here. This 3 means my input for all x's is going to be 3. So it'll be 5 minus 3 times 3. 3 times 3 is 9. 5 minus 9 is negative 4. Using those same functions, f at negative 4 means I'm going to input negative 4 for x. So that's going to be 2 times negative 4 squared minus 5 times negative 4 plus 4. Negative 4 squared is 16. Negative 5 times negative 4 is 20. 2 times 16 is 32 plus 20 is 52 plus 4 gives me 56. Into g, I'm going to put negative 4. So that's going to be 5 minus 3 times negative 4. Negative 3 times negative 4 is a positive 12. 5 plus 12 is 17. You can input anything you want into a function, as long as you hit its domain, which we'll touch on in a little bit. So if you input a number, you typically get an output of a number, but you can input anything you want. Into a function, you can input another variable. It's the same thing. Into the f function, you're going to replace all the inputs, which were x, with a t. So that's going to be 2 times t squared minus 5 times t plus 4. Now t squared is just t squared, and 5 times t is just 5t. So this is pretty much the exact same function that we started with. It's just that all the x's were replaced with t's. But you don't have to just stop there. You can input anything you want. If you wanted to, you could input ABC. And it would be the same thing. 2 times your input squared minus 5 times your input plus 4. It's just here our input is ABC. So 2 times ABC squared minus 5 times ABC plus 4. Now notice we don't have addition or subtraction in here, so we can distribute that exponent and do a squared, b squared, c squared, and then this is just going to be minus 5abc plus 4. Now I know this one's going to look a little funny, f at x plus h. This becomes a very important thing to be able to do if you get into calculus. So same thing, I'm just going to input all of my x's, I'm going to replace them with x plus h. So remember what my original function was, 2 times your input squared minus 5 times your input plus 4. It just happens that my input happens to be x plus h. So 2 times the entire x plus h squared minus 5 times x plus h plus 4. There's no difference between this and the last one, except instead of an a, it's an x, instead of a b, it's a plus, and instead of a c, it's an h. It's just like that last one. However, the big difference comes here. I now have addition inside my parentheses. I can't just distribute like I could in the last one. I will have to write that as x plus h times x plus h. Here, I will distribute my negative 5 to get negative 5x minus 5h, and then I still have a plus 4. We've seen something like this before, where we either distribute the x plus h times x plus h first and then distribute the 2, or distribute the 2 first and then distribute the 2 groups together. I chose to distribute the x plus h times x plus h, so x times x is x squared, x times h is xh, h times x is hx, and h times h is h squared. Now, notice right here, do we have any like terms? Even though this is written x times h and this is h times x, like terms have the same variables with the same exponents. Remember, multiplication is commutative. 2 times 3 is the same thing as 3 times 2. So x times h is the same thing as h times x. So I can rewrite that in the other order. And so now you can see that these are like terms, and I can combine them together to get 2. Now I'll distribute this 2 to all of these terms to get 2x squared plus 4xh plus 2h squared. And I still have this minus 5x minus 5h and plus 4. Now looking here, I don't have any like terms, so I can't simplify this any further. But if I did, I would. All right, let's remind ourselves about domain. So remember, when we talk about domain, domain is the set of variables you are allowed to plug in. These are the things that don't cause us to break one of our rules. Remember what our rules are. Our rules are we can't divide by 0, and we can't take the even root or the square root of a negative number. So if we look at this first function, 3x squared minus 2x plus 6, are we in fear of taking the square root of a negative number? Well, do you even see, or an even root? Do you see an even root with a variable underneath? Nope, so we're not in fear of breaking that rule. Are we in fear of dividing by 0? Do we have a variable in the denominator? Nope, so we're not in fear of breaking that rule. So therefore, we aren't in fear of breaking any of our rules, so there's no restriction. There's no variable a number that you can't plug in for that variable to get a non-real answer, so the domain is all real numbers, negative infinity all the way up to positive infinity. Now for b, g of x equals 2x minus 6 over 5 minus 4x, are we in fear of breaking one of our two rules? And the answer is yes, because we have a variable in the denominator, we need to make sure we don't plug in a variable that makes this whole thing 0. So what we know is that that denominator, 5 minus 4x, cannot be equal to 0. So let's solve for what x can't be. Subtract 5 from both sides. Negative 4x can't be equal to negative 5. Divide by negative 4, and a negative over a negative becomes a positive. X can't be 5/4. It can be any number bigger than 5/4, and it can be any number smaller than 5/4. It just can't be 5/4. So if we look at that at a number line, we put an open circle over 5/4, and we say, okay, it can be any number less than all the way down to negative infinity, and any number bigger than up to positive infinity. When we write domain, we try to write it in interval form. When we use interval form, remember we use parentheses for values we don't include and square brackets for values we do include. But infinity and negative infinity are not real numbers. You can't actually catch them. They're just representations that numbers go on forever in positive and negative directions. So positive and negative infinity will always receive a parenthesis. So here, when we write our domain, we can be anything from negative infinity up to, but not including 5/4, and anything from 5/4, but not including 5/4, all the way up to infinity. So we would write it like this, with the parentheses to mean non-inclusion. And if you have more than one interval that you're connecting, we connect them with a union symbol here that looks like a U. Okay, let's do another example. S of t equals the square root of 3 minus 4t plus 8. Are we in fear of breaking one of our two rules? And the answer is yes. We are in fear of taking the even root of a negative number. So we know that underneath this square root right here, that's a 2, this can't be negative. So what's not negative? A positive, but also 0. Remember, 0 is not positive and it's not negative. It's literally nothing. So that 3 minus 4t can't be negative. That means it must be positive or 0, and we would write that as 3 minus 4t is greater than or equal to 0. So we'll solve this inequality. You solve an inequality the same way you solve an equality, which we don't call an equality, we call it an equation, where you isolate the variable. The only thing to remember is if you ever multiply or divide both sides of an inequality by a negative, then you need to reverse the inequality. A less than would become a greater than would become a less than. So to solve for t here, we'd subtract 3 from both sides. But now our next step is to divide both sides by negative 4. When I'm dividing both sides by a negative, this greater than now needs to become a less than. So now the negative 4's will cancel, a negative over a negative becomes a positive, and we have that our domain would be the t values that are less than or equal to 3/4. We need to write this in domain in interval form, so let's look at this on the number line. It includes 3/4, so that gets a solid dot, and anything less than 3/4. So to write that in interval form from left to right, we start at negative infinity and we end at 3/4, but we include 3/4, so we give it that nice square bracket. That's it for this part 1. I'll see you for next time for part 2.